Hello, welcome to this series of videos I'm going to be doing on hacking the Raspberry Pi with C++, OpenCV, and Qt Creator. I should say at the outset that this project, the source code that we're going to be discussing, is hosted on GitHub at this URL. And what's the motivation for this series of videos? I'm interested in learning about computer vision and machine learning. And so I've been looking into some of the example code and frameworks that are available for doing this kind of work, like TensorFlow and OpenCV. And many of the examples available, the easily accessible ones, are provide the source code in Python, and typically are very focused on particular tasks. So it's difficult to find something that wraps several ideas into an application with a GUI that follows sort of normal software development procedures. So that's what this is going to be. I'm going to scour the internet and get some example code, and I'm going to wrap it into an application with a GUI. The code will be written in C++, and there may be some written in Objective-C, because at some point we might want to push this code to iOS devices. So one of the things that I'd like to achieve with this effort is to have a cross-platform tool at the end of the day. So by that I mean something that you can compile and run on different hardware, as I mentioned, including iOS. And when you're trying to do that, you're limited by cross-platform development issues. Now, luckily, there's been a lot of computer science put into solving these issues, and one product or framework that I found that provides a cross-platform GUI experience is Qt. And Qt is available for iOS. It's available, I believe, for Android. It's available for desktop operating systems, Linux, Mac OS, and Windows. And as well, there's some integration points between OpenCV and Qt. So that makes Qt a reasonable choice for the GUI part of it and for accessing multiple platforms. Now, this, I mentioned, is going to be focused on doing all this on the Raspberry Pi, and however, with a view to cross-platform availability. If you are looking for a video on how to set up OpenCV, Qt Creator, and Raspberry Pi, this isn't really that video. I will give a nod to the complexity of getting those things running on the Raspberry Pi. The Raspberry Pi is a fairly underpowered platform compared to your laptop. So if you're going to be running something as compute intensive as machine learning algorithms or computer vision algorithms, you do want to extract the most you can out of the CPU. So that means getting a compiled version of OpenCV that is optimized for the Raspberry Pi GPU and the Raspberry Pi vector instruction set. As well, you need to get the extra modules built that support OpenCV and Qt. So again, I'm not really going to be discussing very much how to make all that run, but you can see in this window here that this is some of what you need to do to make it happen. You need to get these things going, and you might want to make a multi-machine parallel processing cluster. OpenCV supports multi-core optimizations, and you can parallelize some of these computer vision algorithms that we're discussing in a distributed environment. So you might want to do that. I'm working in a multi-machine environment. You're looking at a Macintosh desktop. However, the Qt Creator IDE that we're going to be looking at is running on the Raspberry Pi. So that involved getting some networking conveniences in place, NFS, that kind of thing. I'm leaking lots of information about my private network, but hopefully no passwords in this. However, as you can see, getting the Raspberry Pi configured to do all this is extensive. If there's interest, I will post what I did to make what you see happen. All right, so that's the talk. So OpenCV, again, if you go to this website, this is the product. It has a bunch of modules. There's a core functionality and several other modules. The other thing we're going to be discussing is Qt. This is the canonical Qt application in C++. So you have an application object, you have a user interface object, and you pass that user interface object to the main widget, which is hosted in this Q application. That is the canonical Qt application. Let's see if we can dig up a canonical bit of code for a Harris corner detector. Where is the actual code? All right, so the Harris corner detector, let's go back to that one. So there's a bit of math involved. We won't look at that right now. The corner detector here is a canonical bit of C code, and we can see that it reads something from the command line, and then calls an OpenCV function to deal with some color space conversions that are necessary. Then it calls an OpenCV, some OpenCV user interface functions to display the demo, and simply waits. And this is what we're going to try to go past in this set of videos. Here is a very slim bit of C code to display a user interface. Here is a very slim bit of C code to invoke a computer vision framework. We want to build on this. This is Qt Creator, and this is the code that's hosted on GitHub in this repository. The main application launcher is very messy. All this code is very messy right now. We're seeing all my experiments. So what we're going to be doing is going to be highly experimental. And so we'll see lots of commented out code. So there is the canonical Qt program. The interesting bit that it hooks up is in here, where we see a bit of code to trap the close event. We see a bit of code we see the constructor where you have some special canonical code to interact with the Qt UI namespace and the objects within that namespace. Here is some code that we implemented to get our particular processing pipeline going. Here is some Qt code to hook up the user interface and get some event handling going on. So what's in the other interesting bit of code that we might look at in this intro? This is a capture object, and this class is responsible for abstracting away the capture layer from the OpenCV layer. So right now, in this main class, we have some OpenCV objects being moved to threads, and this capture viewer is one of them, and the acquisition converter is another. So I'll provide a pipeline for a diagram for this pipeline so that what I'm saying is a bit easier to digest and understand. However, in this class, what we're looking at is essentially where you want to put your processing pipeline. And this fires on a timer, and here in the process method or any other such methods where we pass an object that we get from the video layer, the video capture layer, or the video file system reader layer. We can do some work with this, and when we're done, emit a message providing any listeners with the output from that step in our pipeline. So that's where we're at with that today. The application as it is runs, and right now we have a very basic user interface that we're going to be fleshing out. So it's nighttime and the camera is pointed outside into the dark. This is using the standard Raspberry Pi camera that's attached to the ribbon cable to the camera connector on the Pi's board. It's not a USB camera. So it comes with some software configurable parameters that will allow us to deal with the fact that it's dark and we want to actually see what's going on out there. However, since we have a fancy computer vision framework that we're going to be working with, OpenCV, we'll also go ahead and incorporate into this part of the pipeline some of what OpenCV can bring to the table to clean up nighttime images, for instance. So that's going to be what we're going to talk about in the next video. All right, thanks for watching.